Okay, so it wants us to solve this. And notice it says use the elimination method. The reason we're going to use the elimination method is because these and these are like terms. Do you see that? See how these guys right here are like, and these guys are like. What do I mean by like? Well, I mean as compared to, like, look back, say at like um, look back at number 3. See, these are not like. This is question number 3. Not like, and the right side is not like. Both sides are not like each other. What do I mean? Well, I mean, this has a plain y and this has an xy. So when I say like terms mean same letter pattern. So like terms have the exact same letter pattern. So these guys are not like. One of them's a y, the other's an xy. On this side, we have an x and a number. Here we have just a number. Those are not like. Whereas in number 4, these are like. X squared, y, y. The different numbers, but we don't care about that. Their letter pattern is the same. And these are just numbers, so they're like. Are you tracking with me? I mean, there's no numbers on the right, no letters on the right side. So again, like terms, same letter pattern. Like terms, same letter pattern. So when you have like terms, same letter pattern, that's when you can add them and subtract them, right? You can add 3x squared and 5x squared and get 8x squared, but you can't add 3x squared and 5x because they're unlike. You cannot add, they're unlike terms. Are you aware of that? Maybe I should be saying that. I mean, they assume you know that coming into this class, but I understand you might have been a while since you've taken some of those earlier math classes. I'm glad to help with that. These are unlike terms. So the powers have to be the same, right? So this one, these are like terms. They're both x squared. Their letter patterns are the same. So like terms have the same letter pattern and you can add them and subtract them. Terms that have different letter patterns like x squared and regular x, you cannot add them or subtract them because they're unlike terms. All right. So coming back then to number 5. Excuse me. On the right one here? Yeah, number 5. As we look at number 5, we look and we say, oh yeah, well, okay, I thought I had written, here it is, I put it down here already, didn't I? Yeah, there we go. We look and we say, yeah, they're like terms. X squared, y squared, y squared. They're like terms. So that means we can add them and we can subtract them. So it makes sense to do the elimination method, which is also called the addition method. It goes by either name. The elimination method is the addition method, which means you add them to get things to eliminate. That's why it has those two names. So let me bring it over here. So remember what we want to do. We want to have opposites so that when we add them, somebody will drop out because we don't want both letters. Are you tracking with me? We can't really handle X and Y. We want somebody to drop out so we can get down to just one letter and then we can solve for that letter. All right. So do you realize that they're actually opposites right now? Plus y squared and minus y squared. Those are opposites right now. So we're ready to go. So we can actually add them right now. So that's going to be 1x squared and 1x squared. That's going to be 2x squared. Plus 1y squared and minus 1y squared. Those cancel. 7 and 2 is 9. See how that worked? We added them and y squared was eliminated. That's why it's called the elimination method. It's also called the addition method. You add and they eliminate. And they eliminated because they were already opposites. If they had not been, I would have multiplied one of the equations first to make them opposites, but they already were, so it worked out real nicely. All right, divide by 2. Boom. So we get x squared is 9/2. And then we square root. Remember, we have square root. And remember plus or minus? Hope you're getting the hang of that. When you put a roof on the house, you got to go up and down the ladders, my dorky saying. When you put a root on both sides, you got to remember plus or minus. Very important in this section. Plus or minus. Now, the square root of 9 over the square root of 2 can actually be simplified because the square root of 9 is just 3. Now the square root has to stay on the bottom because you can't simplify the square root of 2. But we don't like roots on the bottom, so we multiply top and bottom by square root of 2. Oops, so we get what? we get 3 square root of 2 over plane 2. Everybody good with that? So 3 square, right, I multiplied top and bottom by square root of 2 to make that happen. And the square root of 9 became plane 3. All right, so now this one says x less than 0, so here we'll go negative. I don't know why I keep putting that root first. 3 square root of 2 over 2. This one, oh, and then down here, x greater than 0, positive 3 square root of 2 over 2. I'm not sure what those other blanks are. I actually am. I'll go ahead and write them in right now. See, both these are x less than 0. They're going to go with 2 different y values is what it is. And both these are x is greater than 0. So I did that again. Look at that. And they're going to both go with different y values. Okay, so I've got 2 different x values. Now, each of those x values is going to lead to 2 y values. So step 1 was right here. I just did step 1. So there's step 1. I added them to eliminate. Okay, now come down here, step 2. Now plug in each x separately. Oops. To find y. To find y. So I'm going to grab the first equation, x squared plus y squared is 7. And I'm going to plug in the first x plus 3 squared root of 2 over 2. So I'm going to plug in right there, x equals plus. Oh, and by the way, you could have plugged into the bottom equation. It doesn't matter. You can grab the first one or the second one. It'll work the same either way. It doesn't matter. All right, so I'm going to plug that one in, see what happens here. So what do we get then? We get 3 square root of 2 over 2 squared plus y squared is 7. Okay, and then we start squaring things. Now, what do? You just got to square the 3, remove the root, and square the 2. So it'll be 9 over 4 times plane 2. Was that too quick? Did you understand that? So I squared the 3 and the 2, become 9 and 4. Now what about the root? Well, it's square root of 4, which is plane 2, isn't it? Or it just removes the root, either way you want to say it. So then that's, and then 2 goes into 4 2 times. So it becomes 9 halves plus y squared is 7. What do you do now? Well, I would just subtract 9 halves from both sides. Y squared equals 7. 7 is 7 over 1 minus, scribbly there, minus 9 halves. Multiply top and bottom by 2. This problem seems to just go forever. All right, 14 over 2 minus 9 over 2. So y squared is 5 over 2. And now, roof on the house, up and down the ladder. So y is plus or minus square root of 5 over 2. We don't want to leave, over square root of 5, because the square root is over the whole fraction. So it's over both the top and the bottom. We don't like to leave roots on the bottom, so we multiply top and bottom by root 2. So y is plus or minus root 10 over plane 2. Right? Plus or minus root 10 over plane 2. Okay. All of that came from what? Where did that come from? Let's trace it back here. It all came from plugging in x is plus, just the plus, 3 square root of 2 over 2. So just the x plus one led to those 2 different y answers, which are what? Plus or minus root 10 over 2. So plus root 10 over 2. Oh, whoop, I better pay attention. Y less than 0. So this has got to be the minus, and then this has got to be the plus. Does that make sense? I'm watching carefully what they're telling me to do. X greater than 0, y less than 0, positive, negative. X greater than 0, y greater than 0, both positive. Okay. And now back here, what about the x less than 0? Well, now we got to plug in the x less than 0. Do you realize? You probably already realized the same exact thing is going to happen. It's not going to be different at all. In fact, I'm not even going to do it. I'll just do step 1 and go dot, dot, dot. Right? If you plug in now negative, am I losing? There's so many steps here you can get lost. Let me back up. Let me make sure I'm not losing you. From the beginning, I took this thing, added these guys up, these y's cancel, got x, got a lone, but when you put a roof on the house, up and down the ladder, so I get 2 answers for x, plus or minus 3 root 2 over 2. So I wrote in the 2 negative x answers, and I wrote in the 2 positive, the negative x answer in 2 spots, and the positive x answer in 2 spots. And now I plug in the positive, and I worked that through all the way down here, and it came out 2 y answers. And now, let me separate this. There we go. Now I'm going to plug in the negative x answer to this equation. So I plugged in the positive, plugged in the negative. See, it's going to be the same. It's going to be negative. Why do I always put that root first? 3 root 2 over 2 squared plus y squared is 7. Do you see if you square that, it's going to become 9 times 2 over 4 positive, just like this one was. It's the same. Plus y squared is 7. It's the same. So I'm going to go dot, 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 then y is plus or minus root 10 over 2, right? Isn't that what we began with? Yeah, there it is. It's the same. It's going to be exactly the same. Everything's the same from that point forward. So, of course, it makes no difference whether you plug in negative x or positive x if they're the same number, because you're plugging into x squared. So that gets rid of the negative sign, doesn't it? It makes no difference if you plug in a negative x or a positive x. X is being squared, so it's going to come out positive eventually, isn't it? So y is going to come out the same. So the 2 y answers are the same. So they want y less than 0 here, so this will be negative root 10 over 2. Y greater than 0, positive root 10 over 2. And there we go. We got all 4 answers. One more time to recap. What did we do? We added the 2 equations because the y squareds were already opposites. Excuse me. And so these y's canceled when we did. We got 2x squared is 9 halves. Solve for x, up and down the ladder when you put the roof on the house. Got those 2 x answers, plugged in the positive and the negative x values to either one of the first 2 equations. It doesn't matter. If you did the other equation, it'd come out the same. It doesn't matter. Worked it through and found y is plus or minus 10 halves, root of 10 over 2. And the other side's the same. So the y values negative and positive root 10 over 2. And again, negative and positive root 10 over 2. So there's how we get our 4 different answers to that question. There we go.